Now we will describe the convolution theorem. So what is convolution theorem? Let f1t and f2t be two functions. Be two function of t such that Laplace transformation of f1t and f2t exists. That is, L of f1t is equal to f1s and L of f2t is equal to f2s. Okay. Then f1 convolution f2, this is equal to integration 0 to t f1x f2 tau minus x by f2 t minus x dx. Okay. Or we can write integration 0 to t f2x f1 t minus x dx. Okay, clear? Anyone. You can consider f1x at first, or you can consider f2x at first. If you consider f1x at first, then f2t minus x. If you consider f2x at first, then you consider f1 t minus x, and we have to integrate with respect to x. And what is the range of the integration? 0 to t. Okay. If it is satisfied, if it is satisfied, then f1 convolution f2, then Laplace of f1 convolution f2, this is equal to f1s into f2s. Okay, clear? Clear? So what we are getting? Laplace of f1 convolution f2 equal to f1s into f2s. Now, so what is the conclusion? Conclusion, if we have to find the inverse Laplace transformation, that is f1s into f2. Suppose f1s into f2s is given, and we have to find the corresponding f2. What do you have to do? f1s into f2s is equal to Laplace of f1 convolution f2. Therefore, L inverse of f1s into f2s is equal to f1 convolution f2, and what is f1 convolution f2? This is equal to integration 0 to t f1x f2t minus x dx. Clear? Yes or no? Yes. So the inverse Laplace transformation can also be solved by with the help of the convolution theorem. Okay. Now come to the question. question. Find ft if fs is equal to 1 by s plus 1 and s minus 2. Okay? Solution. Fs is equal to 1 by s plus 1 into s minus 2. This is equal to 1 by s plus 1 into 1 by s minus 2. This is equal to f1s into f2s. Same. Therefore, f1s is equal to 1 by s plus 1, which implies L inverse of f1s is equal to L inverse of 1 by s plus 1 is equal to e to the power minus t. This is equal to f1t. Similarly, f2s equal to 1 by s minus 2 implies f2t is equal to e to the power 2t. Okay. Now, L inverse of fs equal to L inverse of 1 by s plus 1 into s minus 2 is equal to L inverse of f1s into f2s. This is equal to f1 convolution f2. This is equal to integration 0 to t f1x f2 t minus x dx. Now what is f1x? f1x is equal to f1t. What is f1t? f1t is equal to f1t equal to e to the power minus t and f2t equal to e to the power 2t. So this is equal to integration 0 to t e to the power minus x, because f1t equal to e to the power minus t, f2t equal to e to the power 2t. So e to the power minus x into f2t minus x, that is e to the power 2 into t minus x dx. This is equal to integration with respect to x. So e to the power 2t, we can take it outside of the integration. E to the power 2t integration 0 to t e to the power minus x into e to the power minus 2x dx. Okay. This is equal to e to the power 2t integration 0 to t e to the power minus 3x dx. This is equal to e to the power 2t e to the power minus 3x by minus 3 0 to t is equal to e to the power 2t into e to the power minus 3t. We can take minus 3 outside. E to the power minus 3t minus e to the power 0, that is 1. So we are getting the minus multiplied by minus. So e to the power 2t into 1 minus e to the power minus 3t divided by 3. This is equal to e to the power 2t minus e to the power minus t by 3. Therefore, L inverse of 1 by s plus 1 into s minus 2. This is equal to e to the power 2t minus e to the power minus t by 3. This is equal to empty. So very easily we can find this. Very easy. So in this way, by using the convolution theorem, we also find the inverse Laplace transformation very easily. Okay, clear? Now to the next question. What is the next question? Suppose it is, next question. L inverse of s by s square plus s square whole square. Okay. So here, solution. Here, fs is equal to s by s square plus s square whole square. This is equal to s by s square plus s square into 1 by s square plus s square. Therefore, this is equal to f1s into f2s. We know that L of cos at equal to s by s square plus s square, and L of sin at equal to a by s square plus s square. Therefore, f1 is equal to s by s square plus s square implies f1t is equal to cos at. And f2s, this is equal to 1 by s square plus s square implies f2t is equal to sin at by a. Okay, clear? Therefore, L inverse of 1 by s by s square plus s square whole square equal to L inverse of s by s square plus s square into 1 by s square plus s square. This is equal to f1 convolution f2. This is equal to integration 0 to t f2x into f1 t minus x dx. This is equal to what is f2x? Sin at by a. So integration 0 to t sin ax by a into cos a t minus x dx. We can take 1 by a outside, then multiply it by 1 by 2, integration 0 to t 2 sin a cos b dx. What is the formula? We know that sin a plus b equal to sin a cos b plus cos a sin b, and sin a minus b is equal to sin a cos b minus cos a sin b. If we add, then cos a cos sin b, cos a sin b will be cancelled. So we are getting 2 sin a cos b equal to sin a plus b plus sine A minus B. Clear? So 2 sine A cos B means this is equal to 1 by 2A integration 0 to t sine A plus B, so plus AT minus AX. Sine A plus B plus sine A minus B. AX minus A into T minus X dx. Okay, clear? This is equal to 1 by 2A integration 0 to T AX cancel sin AT plus AX minus A minus plus AX. So 2AX sin 2AX minus AT dx. Now this is equal to 1 by 2A integration 0 to T. Now what is the integration? Sin AT dx plus integration 0 to T sin 2AX minus AT dx. So let 2AX minus AT equal to P. Therefore 2A dx equal to dP. So what we are getting, this is equal to 1 by 2A. What is the integration? It is with respect to x. So sin AT into x. Sin AT is constant. So integration 0 to tx within the range 0 to t plus integration sin this. So sin p. Now what is dx? Dx equal to 2p by dA. 2p by dA. Now we have to put the range. This is the range of x. If x is equal to 0, then p is equal to minus 8. If x is equal to 0, putting here x equal to 0. So 2a into x is equal to 0 because this is the range of x. So putting the range of x equal to 0. So we are getting 2a into 0 minus 80 equal to p. So p equal to minus 80. And what is the upper range t? So putting x equal to t. So x equal to t, we will 2at. So 2at minus 80 is equal to p. Then 280 minus 80 equal to 80. 80 equal to 80. Okay. This is equal to 1 by 2a integration. So if we put t equal to x, t will be x equal to 0, 0. So t sin 80 plus what is the integration of? So 1 by 2a. What is the integration of sin p? Sin p integration is cos p and this is minus. Okay. Range minus 80 to 80. This is equal to 1 by 2a t sin 80 plus 1 by 2a. Now putting 80, we are getting minus cos 80. Then minus a plus cos, this is minus 80. Cos minus 80. Cos minus 80 means cos 80. So cos 80. Okay? Because cos minus theta is equal to cos theta. Why? Because cos theta is a even function. Okay? So cos 80 cancel. We are getting clear? Yes or no? Yes. So we are getting 1 by 2a t sin 80. So therefore, what we are getting L inverse of s by s square plus s square whole square. This is equal to t sin 80 by 2a. 28. Okay, clear? So in this way, with the help of the convolution theorem, very easily we can find the value of the inverse Laplace transform. Now another important question that is very important. Using Laplace transformation, find the value integration 0 to t cos x sin t minus x dx. Okay? Now with the help of the Laplace transform, that means we cannot do this integration directly. We have to use the Laplace transformation. How we can use? So this is look to the in range of the integration. This is 0 and this is t. This is a range of the convolution theorem when f1 convolution f2. So what is the first function? One function is cos x, another function is sin t minus x. So it is simple f1x into f2 t minus x. Now solution. We have to find the value integration 0 to t cos x sin t minus x dx by using Laplace transformation. Okay, clear? Therefore, what is f1t? Therefore, here f1t is equal to cos t, f2t equal to sin t. So it is looking like this. Therefore, integration 0 to t f1x f2 t minus x dx. This is equal to f1 convolution f2. This is equal to L inverse of f1 is into f2s. And now if f1t equal to cos t, this implies f1 is equal to s by s square plus 1 square. And f2t equal to sin t implies f2s equal to 1 by s square plus 1 square. Therefore, L inverse of s by L inverse of f1 is into f2s. This is equal to L inverse of s by s square plus 1 square into 1 by s square plus 1 square. Now it's like as before, very easily. Already I have explained it in the lecture 3, how to find the inverse Laplace transformation. Use it, write it in the partial fraction and do the inverse. So can you do it? Or I have to do it? Okay, come here. S by s square plus 1 into 1 by s square plus 1 square. Okay? How we can do it? How I can do it? S square plus 1. S square minus b square minus I square. S square plus 1 square can be written S square minus I square. Okay, minus I. So this is equal to S square minus B square, S plus I into S minus I. Okay, clear? So this is equal to S by S square minus I square, and this is whole square, is equal to S by S square, sorry, S plus I into S minus I. This is whole square, this is whole square, because it is whole square. This is equal to A by S plus I plus B by S plus I whole square. Already I have shown it in the last lecture. C by S minus I plus D by S plus I, sorry, S minus I whole square. Now as like as before, find the value ABCD, do the LCM, find the value ABCD and find the Laplace. Okay, this is S plus I. Whatever with the, what is the inverse? E to the power minus it. What is the inverse? T into e to the power minus it, because denominator square. What is the inverse? This is plus, so it will be minus e to the power minus it. This is whole square, e to the power minus it into t, t into e to the power minus it. Here it is minus plus, e to the power t, and again whole square, t into e to the power t. Okay, just we have to find the value of ABCD. If you forget, see the lecture 3. See lecture 3, inverse Laplace transformation. Okay, very easily you can find the value ABCD, put the value ABCD and take the inverse, you'll get that. This is the, find the value of the integration with the help of the Laplace transformation. Okay, clear? That's all for today. Okay.